All right, welcome everybody to this session, the MMS Treasure Hunt. My name is Andreas Hammarskjöld. I come from a company called Atea. Together with me, I have two of my assistants, Mr. Phil Wilcock, who will introduce himself, and we have our silent little friend here in the front, Mr. Rootard, who's actually in charge of the technology on the front. But he doesn't speak a lot. So I'm not going to talk much more. Instead, I'm going to hand over to Phil. I'll be handling all the demos, and Phil will do a lot of talking around the actual technology that we'll be showing today.
Hello. Okay. So a few assumptions. We are assuming that everyone's fairly familiar with Config Manager. We won't be going too much into the admin console and the Config Manager side of things, because a lot of what we found here is delving into log files and weird and wonderful places. There's a bit of networking, so if you are going to test this in your labs, it's useful if you've got some telnet skills, notepad skills, scripting, command line prompts, PowerShell, NetShell, all of that kind of good stuff. And what we're going to be talking about is making the most of some features that are in Config Manager 2012 Service Pack 1, which are not particularly well documented, or have only recently been slightly documented, or are actually not documented at all. And the objective, really, of today is to get you to a point where you understand how these technologies work a bit better, and hopefully you'll be able to go away and get them up and running in your own labs, because they are useful features and it's native functionality, so we might as well make the most of it. Now, the third item on there, hybrid media, we will talk a little bit about if we have time, but we've got a lot to cover with the first two topics, so we'll do our best, but there's a slight gotcha in terms of demoing hybrid media, which we'll mention at the end. So, Wake on the LAN. It's been around a long time. It's been threatened to be included in Config Manager for a long time, and it has been around for a while in Config Manager. What we found when we looked into this is that there was a lot of good stuff done by Microsoft Research prior to its inclusion in Config Manager, and this is where a lot of the original ideas and some of the core code for the Wake on LAN proxy came from. So if you want to get to know it better, I'd recommend that you have a good look around here, because the guys that have written this stuff are really, really good. There's a team of about 8 people. There's algorithms. There's a real depth of knowledge in there. So we thought we'd better give them a bit of a name check. So the problem that we're trying to solve with Wake on LAN in general is the age-old problem. We have a desktop machine, used often, sometimes idle. You may have power schemes in place. We really want to be saving as much energy as we can. So good practice dictates that we're powering off our machines, or at least having a power policy whereby machines are going into standby or hibernate. But obviously the flip side of that is that the machines aren't always available. And that's availability in terms of Config Manager patching, general IT admin stuff, or perhaps even a remote user that wants to access their desktop from home, which is more common these days. So the savings are there to be made in power management, but the bottom line is that we need the systems to be available. And so there's a brief history here of Wake on LAN in Config Manager. And it was introduced in Config Manager 2007. Is anyone here actually using Wake on LAN in that iteration? Couple, okay. It was a fairly standard implementation, so it relies on a subnet directed broadcast or unicast. 2 flavors. You had the option, select it in the console. But the problem with Wake on LAN as a technology, in its interaction with the network, is that both methods have drawbacks. So unicast is kind of okay until your client's been off for quite a while and then the MAC address is dropped by the network hardware. Subnet-directed broadcasts are an even bigger no-no, really, because that's usually disabled by default these days at the network level by the network guys. So it's usually quite an unpleasant meeting trying to get that one fixed. So the wall proxy solution came along recently in Service Pack 1, and it gives us a whole bunch of functionality, and it really makes it more usable. It really makes it the difference between it being usable and not. The server-side component's really unchanged. So in terms of the way it works, you have the Wake on LAN manager component on the site server side, and the Wake on LAN comms manager sends out the Wake on LAN requests, and it still acts in pretty much the same way. The way that it differs basically is with the inclusion of the sleep proxy, which is a client component. So in order to roll that out, you basically just need to enable it in the client settings, check the box, say that you want to roll the client proxy out, and off it goes, and it does that. It also does some cool things on the client side in terms of if Wake on LAN isn't enabled, it will generally try to enable it in terms of the NIC settings, which is another kind of a stumbling block that you may become, although these days adapters tend to be enabled rather than disabled. So sleep proxy, what does it do? Well, it enables the machine, the goal of a sleep proxy enables the machine to have all of that good power saving capability, so it can be physically asleep or standby, but available on the network. It may still require some network tweaking, which we will cover. So although to some point we're getting past the whole unicast subnet broadcast issue, while we were actually delving into this and testing it, we found a slight problem in that we borrowed this switch and nothing worked. So we just presumed that it was us, or config manager, or the client, or that we were just being really stupid. But it actually turns out that it was quite a good discovery because we can share it with you. So the client component, once you've got that rolled out, got your network actually tweaked, if it needs to be, how does it actually work? So this is the basic concept of how a sleep proxy works. So what we've got here is the client machine. The client agent basically sends a sleep notification to the sleep proxy. The sleep proxy takes over the MAC address and the IP address for that client. So as far as the network is concerned, the sleep proxy is that client. So it makes it still available. Now, when a computer sleeps, the sleep proxy takes over, but obviously you've got to be a little bit clever about how you react to traffic from that client. So the proxy agent is pretty much ending up with a list of clients that it's got on that subnet, and it's got to decide what to do with all of the traffic for each of those clients. So what the guys at MS Research came up with is the concept of a reaction policy. And what we want to do is we want to respond to some traffic, so ARPs, that kind of thing. We need to respond to that so that we're looking like the client is still there. We need to wake for some traffic when it's relevant. Obviously, you don't want to be waking the client every time something comes along, because there's a lot of network chatter out there that can simply be ignored. So the third item there is we're just going to ignore all of the rubbish and put some intelligence into when we actually decide to wake the machine. And ultimately that determines your energy savings, because if your machines are just going up and down all the time, then you're not going to be getting that good power management energy saving. So the sleep proxy in a little bit more detail. The sleep notification consists of the MAC address and the IP address, but also the ports that that client was listening on. So we've got what we end up with is a list of not only the clients, the MAC address, etc., but you've got the ports that they're listening on. So if you've got a specific app that's listening on a port, that is retained by the sleep proxy. So the sleep proxy then does an ARP probe to the network, so it looks like the client's still there. So that when the remote user tries to remote into the machine, it's actually remoting into the sleep proxy, which then wakes up the client, and the client reacts and ultimately gives control back to the client. And the client, when it wakes up, then does its own ARP probe and says, look, I'm back, I'm here. As far as the network's concerned, it's just moved on to a different port. So the remote user, in this case, remoting in, eventually sees the machine as if it had always been there. Now the timings on this, it's about 9 seconds, which isn't too bad really in terms of being able to use a machine. But the clever thing that the sleep proxy does, it actually retransmits some TCP SYNs, because if the client's not quite awake, then it's going to miss some of that traffic. So the proxy has quite a lot of intelligence. And it's a bit more belt and braces as to how it actually wakes the client. So how is this actually implemented in Config Manager? Slightly later project at MS Research came up with an application called GreenUp. And this is closer to this actual implementation, and what they decided there was rather than just have a single sleep proxy, you need to have several. The reason for that is obviously because these machines are in use by the users, you need a level of redundancy in there. So if someone's PC happens to be the sleep proxy and they power it off, it's good to have a couple of others on standby. So the default configuration is that we have 3 PCs on the subnet that are taking care of the Wake on LAN proxy. There's a manager which is doing all of the actual the waking up, etc. at that point in time. Then we have 2 guardians who are kind of on standby. So if the manager goes down, there's a process to decide which guardian will take over, kind of depending on how busy the machines are, and several other criteria. The number of guardians is configurable via policy, but I suggest that you don't really mess with that because 3 is pretty much the right number. There's some load balancing involved. The manager actually hands off some of the work to the guardians, and it's quite complex. So 3 machines, the default configuration is what I would recommend that you stay with. So there's a summary of what happens. The manager basically, in the sleep proxy role, compiles a list of all of the clients that it's going to listen for. And obviously, if you create a deployment in SCCM, the site server is going to send out the Wake on LAN packets as normal, just using unicast, because unicast is a requirement if you're using the proxy. And because the sleep proxy has ensured that the ARP cache is still populated with those clients, they'll still be woken as usual. So what the proxy is actually doing is simply enabling the unicast to arrive at the client. There's a lot of checks built in there in the Guardians, and when you'll see that in the log files when we show you in the demo, there's a lot of checking. So if a Wake on LAN packet fails to go out, another Guardian will try. There's a lot of pinging. There's a lot of checking that clients are asleep. And one thing that we did find, which was quite interesting and undocumented, is that every day at 2 o'clock it does an enormous roll call and wakes everything. So that was quite puzzling when we were practicing the demo at 2 o'clock and things just started bing, bing, bing. And so digging into that, obviously there's a lot of detective work involved here. And the reason that it does that, it creates a roll call window of 10 minutes. And in that time it checks to see everything that's awake, and it's kind of a refresh on a 24-hour basis to see just what's out there. Because obviously if you've got laptops that have moved off the subnet, machines that have moved around, it makes sure that the cached information in the Guardians is up to date. So I'm going to hand over now to Mr. Rue, Anna, and Andreas.
Perfect. So let's take a look what this looks like. So first of all, in the console, what you have is the new little drop-down box to enable wake up or not. You can see we have a little bit of configuration that you can do. And what happens when you actually check yes is that the wake up proxy, which is the MSI, which is actually then within the SCCM cache folder, or as of the actual where the client installs. That installs the client, and what you get is basically a service called Wake Up. Let me see here. Configuration Manager Wake Up Proxy. So that service, if you dig more in detail to what that actually does, by looking in the registry, you can actually see that it's a service and running the sleep agent service, but it also has two dependent services. And those dependent services is actually what's listening on the network. So you can see the SSN DISPROT and the SSN PS. That is actually network monitoring protocol to monitor everything that's happening on the network. So together with basically the client settings, which is something that you could see in the actual, so this setting, is basically in the actual config of the machine. You could see that there are a few of these settings that you can actually see in the local policy that are not actually visible when you look at the console. So here you can, for instance, see the max number of days to keep, the port is in the console, but the max per machines per manager, and also the little setting above it, which is basically the number of managers, how much CPU are we allowing for the clients to have before it's actually canceling down and say, I'm not going to be a manager because I'm too busy taking care of the network. So there's a lot of settings in here so that you can dig around and actually try. So let's take a look and see how this works. So what we're going to do is, if I go to my switch here, you can see that we have my 3 machines in front of me, right? So let me type in my commands, and I'm going to show you. So from a switch perspective, this is what you see. And this is what we call as the ARP, which is basically the switch knows which port, which IP, and which MAC is sitting on that port. So if we wanted to, what we're going to do is actually shut down Orange. So we're going to use one of our TS tool to do this. So basically put the machine to sleep. And you should see up here, unless Rootard's hiding it, that Orange actually went to sleep. Did it? So if I then press wake on LAN to wake it up, the laptops sadly don't refresh their screens. Let's see. Maybe I didn't really click it.
Oh,
is that great?
Here we go.
Oh, wrong machine. So that's how it uses the ARP cache. So it knows the IP address and the MAC address, and it sends a command to do a wake up. So I did a unicast wake up. So my server is on a completely different subnet than my clients. So we have the switch sitting back here. But as we saw earlier, how does this happen then when the ARP cache basically extends out and is cleared out of the router's switch? So what we're going to do is we're going to, first of all, make sure that they're all on.
They're all on.
They're all on?
They're all on.
So then we'll do a little quick. We'll put Orange to sleep. And let's go back. Is Orange asleep?
Mm-hmm.
Let's take Blue and basically put him to sleep as well. Is Blue asleep as well?
He's gone. Blue is
He's gone. So let's switch to the log file. And it's a little bit hard to follow, but you can see that these machines, we have 4 laptops here. I powered down 2. We know that we have to have 3 machines at least running. So basically, this guy now he's becoming a guardian. And he should see now from the network traffic that we don't have enough machines, and actually woke up Blue to make it a guardian. So I think if I wiggle the display here, you can actually see that it sent wake on LAN packages to wake that machine up.
That's Blue.
Is that Blue?
Yeah. It's awake.
All right, perfect. So that's kind of how it works. So there's a lot of information within the log that you can actually see. And some of the information is basically the broadcasts where it see a machine going down, it will basically say, hey, this is the information that we need to update the switch with. So if we go to the switch, you should be able to see that to see here what my show Mac address table for the dynamic for the VLAN 11. So what you can see here is that we actually only have 3 ports active. One of the MAC or 2 of the MAC addresses are actually registered for the same port. So that's a bit weird, isn't it? So what the machines have done is said, we can see that one of the machines is actually powered down, which is orange, and we said, this is the guy that we will be taking care of. So if I try to actually go and access something on orange, you should be able to see that it wakes it up. And the interesting bit, what it does, is that it takes the active ports. So that's that. So anything of the ports that the machine basically listens to. So if you have enabled remote desktop on your clients, it's basically the machine is listening on 3389. Normally, if you have like allowing the firewall to let through 135 and other services, that will basically wake the machine up if any other basically command is trying to use it. So we can demo this. Hopefully, if my machine is the machine, we should be able to see. So let me see. Yeah, so orange, let's try to go and say 554. So what we're basically trying to do is trying to get some information down to on the port 554 to orange. We should see in the log file here that we see probably one of the other machines are acting as the, so let's go to Blue's log. It's a bit hard to actually show this in a because it's completely dynamic, who is the manager and who takes care of it. So,
and sometimes it happens really quickly, and sometimes it takes a long time.
So, but here you can basically see that we woke orange due to a sin on 554. So basically decided that this was a port that we were actually trying to use and what the machine was using. So not only will you be able to use Wake on LAN, because the guardians will see the Wake on LAN packages coming down to the machine, you can also allow people from home to remote in, or if a server is actually trying to go and update the antivirus definitions, or using File Explorer, or anything that's basically the machine is set up to manage. So that is a pretty cool feature of the wake-up proxies in Configuration Manager. So I think basically what we're going to try now is to show you how you basically can completely destroy this. So let me go back to my machine here and show port security. So every modern switch and router has a lot of functionality to secure and lock down the network. With the Cisco switch that I'm using, it's a layer 3 switch, so it does all of the IP routing on the actual switch side, which is a fairly common method of doing things today. You normally don't have a router that then's connected to a switch. You do all of this routing within the switch itself. So what we're going to do is that you can see that port 1, port 9, and 10, they actually have port security set up. So I'm going to take one of my little commands here, which is basically everything needed for all my ports to set port security. So let's go crazy in here. Paste all of that. Write that to the memory configuration. So what happens now is that we don't have the right to do show port security. You can now see we set the maximum amount of MAC addresses to 1 per port. So even though the guardian will then say, hey, I want to tell the switch to manage the other guys as well. The switch will basically tell them, nah, you're not allowed to do that. And then you also have something that's basically, as you can see, the security action over here. It's basically what to do. And the switch that we got configured from our network team, we basically, the guy that I asked which port he asked me, so should I put my standard configuration on it? Yeah. And he was very security oriented. So he was basically locked down as much as he could when I got it. But the default setting from Cisco is that it allows quite a lot of actual change. The support security on Cisco switches is not actually enabled. But basically, if we have all the 3 machines up and running here, and we press down orange, and we press down blue, we should be able to see when we refresh here, maybe a little bit too fast. See the things here, it takes some time. You can see here, we actually on port 6, that was the manager saying, hey, the guys went down, I'm going to try to update it. But you can see the network count for the actual entry is 1. So what we got was a security violation from the switch basically saying, hey, you guys are not allowed to do this, and what are you going to do? So normally what would happen in a really secure environment, it would actually power down the port for you. So you lose the network connectivity on the Ethernet level between the switch and the wake-up proxy. So there is a little bit of configuration in order to get the Guardians working, but most of the cases, I think it will be actually enabled on the switches that you run these things on.
Yeah. So the question you need to ask your network team is, how do you feel about MAC flapping? That's the term.
Yeah, and the MAC flapping is basically when the other clients say that the MAC address is now over on this port. So, yeah. That's kind of it, what I had to show around the Vault proxy stuff.
Okay. What number are we on here?
Number 5.
Okay. Great, so we'll take some questions at the end, but hopefully you're okay with that and you'll have enough to go away and get really excited about Wake on LAN. It's not the sexiest technology to demo, but I hope we will have illustrated just how it works in SCCM or just how it can fail. That last line there is incorrect, but we left it in because I thought it illustrates quite well that along the way we find things that we think we're completely convinced about and turn out to be completely wrong. So RDP works fine and it's nothing to do with port 445. So we're going to move on now to branch cache. Anyone actually using branch cache aggressively? Few people. Good. We're going to talk about branch cache. There's some of the new features in branch cache both in Server 2012, Windows 8, and SCCM. So again, what we're coping with is a really familiar and quite an old problem, which is how do you service clients at branches? Or how do you service clients at branches without really annoying somebody, without flooding the network and getting in trouble? Branch cache support basically came in with SCCM 2007, SP2, and it was also introduced into Server 2008 R2. And what it does is to enable a single download serverless offices, which is obviously great. If you've got a bunch of offices that have only got 5 or 6 clients, then we really don't want to go down the road of putting more hardware out there. So it's all about sharing, and it's all about sharing at the local site level. Branch cache and SCCM, there are 2 modes that branch cache operates in. There's distributed mode and there's hosted mode. The one that SCCM utilizes is distributed mode. Hosted mode is more geared towards sites with multiple subnets, and you can have servers there that can service those multiple subnets. But in distributed mode, the restriction on that is that the client will only share within that subnet. So if you do have a site with multiple subnets, what you need to watch out for is that there will be one download per subnet. So the architecture, the way it works, is fairly simple. The client gets the content from the branch cache enabled distribution point, and then shares the content with other clients on the subnet. Fairly straightforward. In order to enable branch cache, there's a enabling within the server side of things. In the SCCM side of things, all you need to do is make sure that you configure the package correctly. So it needs to be a download and execute. So some of the new features, which is what we're really talking about today, and what makes it a lot more interesting. There's some new Windows 8 client functionality. There's a lot more that you can enable, and there's a lot more intelligence on the Windows 8 clients. Another really important point is the native data encryption. If you wanted to secure your data in the previous version, you had to basically use some certificates and maybe BitLocker as well if you wanted to be ultra careful. But now branch cache itself encrypts everything in the cache natively, so we kind of do away with that requirement. There's some new PowerShell functionality as well, which enables you to do many things, but the one that we're really interested in today is giving you the ability to pre-stage data. And the reason that's important is if you've got really large packages, even copying it once across the network can be an enormous hit. And obviously if you've got multiple subnets, it's going to happen once per subnet. Pre-staging lets you take the package data and stick it in your pocket in a USB stick and go and plug it into a client. So that's the major change that we're looking at, really. But I thought we'd go all cloudy, because everyone's being cloudy at this conference. Thankfully, this demo doesn't rely on the internet, I like to say, ironically. You can now stick a distribution point in the cloud. So in some scenarios, that could be quite useful. So if your company was to buy another company on the other side of the world, you can put your SCCM distribution point. You can host it in Windows Azure now as of Service Pack 1. You can choose the geographic location to a point, which will also help. But also, if you use branch cache, you can effectively save money, because as you know, with the Azure pay-as-you-go model, the more data you download, the more data you transfer, the more you're going to pay. So we're going to use branch cache to avoid bill shock, should we say, in that scenario, because if you have a bunch of SCCM clients all pulling OS updates from your Azure server, you'll soon run out of cache. There's some really good articles, actually, about how to implement your distribution point in the cloud, and also how to enable branch cache in doing that as well. So I recommend that you hunt those out. So pre-staging the content is really important here. That's what we're really interested in today. But I'm just going to clarify something. There's been a lot of talk in various forums and confusion as to what functionality is in which client. And in terms of what we're talking about today, Windows 8 Pro has the platform APIs and bits, which is fine, really, for SCCM work that we're going to do. Enterprise has a little bit more. So Enterprise has the HTTP and SMB integration, which is kind of geared towards having extending your file system into the cloud effectively. But it's not a requirement really for the SCCM stuff that we're going to look at. Windows 8 Core actually doesn't have any support, so just to clear that one up. And the best combination really is Windows Server 2012 with Windows 8 clients, because you get the best of both worlds. You get the native encryption, and you get some other features. Just a couple of useful commandlets that give you an example. There's a whole list of new commandlets on TechNet in terms of branch cache, both on the client side and the server side. So we can do things like set the location of the cache, we can set the percentage of the disk that we want to use for the cache, and you can clear the cache just from the command line. So that's useful if you're going to be testing packages, because you want to be making sure that everything's cleared out before you redo your tests, because it's quite tricky, as you will see, in terms of figuring out just when the client is going to the server or going to its peers. So you need to be quite diligent about how you manage the caches and clear them out in your testing. So I'll just go into a little bit about content information, because it's quite important, especially in a mixed environment. The way that branch cache works is it processes the content, so it processes the files that consist of your shared branch cache content, and it creates what it calls content information. Now that just consists of hashes of the content itself. So when a client gets stuff from branch cache, it gets the content information first, and then it does a broadcast to see if anyone else on the subnet has got that content information. And this is what enables branch cache to significantly lower the traffic between the server and the client. The content ratio is approximately 2,000 to 1. So the content information is pretty much 2,000 times smaller than what you're actually going to deliver. The slight gotcha here is that there are different versions of content information. Version 1, which is kind of the Windows 7 version, uses larger file segments, and it's a bit less efficient because, for instance, if you get a changed file, if you have quite a large file and it's changed, the version 1 content information, the way it decides where to start getting the changed information is not as clever, and it tends to, it will not necessarily download the whole file, but it will download it from the point where the file changed to the end of the file. So it's not quite as intelligent. It's still a big bandwidth saving, but version 2, which is the Windows 8 version, uses a much cleverer algorithm, and it uses variable size segments. So if you do have a change that, to a file or a bunch of files, you're going to get a lot less data coming down. Version 2 is only available with Server 2012 and Win8 clients, and the slight gotcha there is that the clients don't, the version 1 and version 2 clients don't share information. So if you have a subnet and you have some Win 7 machines and you have Win 8 machines, Windows 8 machines get the branch cache content. It's not going to, by default, share it with those Windows 7 machines. So you need to watch out. But you can configure the server to only use version 1 content. So if you've got a mixed environment, you can get around that, but it's just something to look out for. So the specific aspect of branch cache that we're going to look at within the demos is the pre-staging. And it's very simple. It involves these 3 commands. The first 2 run on the server, and the third runs on the client. So publish file content tells branch cache on the server side to create that content information. So then we end up with a package that consists of the content information and the data itself, which gets rolled into a zip file and exported. And then we take that onto our little USB key and import, which is a single command, and that populates the local cache. So I'll just demonstrate that here. So on your branch cache enabled distribution point, you can go along, run these 2 commands to export the data. You can put it on a USB, you can put it on burn it onto a DVD. So that creates the content file, and then we take that. Obviously the difference with the previous slide is that nothing's crossing the network at this point. Then on the client, we perform the import, and that populates the client cache on the Windows 8 machine. And from that point onwards, basically, in distributed mode, we're back to the sharing model of the older version of branch cache. So a client 2, for instance, would know that something was available for it, but it would do the broadcast and see that client 1 has it in its cache and get it from there, and so on and so on. Okay, so there's enough talking for now. What we need to see is some action. So I'm going to hand you back to Andreas.
Perfect. Okay, let's take a look here. I'm logged into my configuration manager server, and just to show you the PowerShell commands that Phil was talking about, basically run the get command module of branch cache, and you can see all of them. We'll be using some of them in the demo, but just wanted to show them to you. So in the configuration manager environment, you normally have, I think I had it up here already here. What you have on the client, or on the basically the settings for packages and applications, on the advertisement, you basically have a checkbox to say, yeah, this is what we want to run on we want to use branch cache for applications and packages. But if we go out and we look at the task sequence, so I've created a little dummy task sequence that I'm going to use in my demo. If we look at the deployment of that, you'll see that the actual peer-to-peer option is no longer there. So for your packages and application, you can tell Configuration Manager to use branch cache. But for task sequences, which is often larger data, there's no option to do that within the console. So we started digging around, and we thought that, of course, this has to work. Why would they enable it not to work for task sequences? So what we did was to find that it's actually using basically what I'm going to take up for you guys here is basically the property for this advert that I've advertised my task sequence for. So if I zoom in, you can see that this value is basically the default value, or not the default value, that you have when you advertise a task sequence. So what it is that if you take that value and put that into a calculator as a decimal, no, it was hex, wasn't it? Hex. And you basically turn that over to binary, you will be able to see, and this is how a bit flag within Config Manager works. It's basically, well, one bit, that means that a feature is enabled on the advert. So the default one is that it's actually using this guy. And you could see that what they're doing, calc, whoops, is type it in as hex. We're going to compare these bad boys, and you will be able to see that one, where if you go in and enable branch cache and a normal package and normal advertise, you'll see that it sets the 17th bit of the advertisement. Completely undocumented. In the old SDK, there is a use of that flag, but it's not documented whatsoever that this has to do with branch cache. So we thought, well, what will happen then if we set that on a task sequence and send that out to the client? Well, why don't we try to do that, but before we're going to do an actual show the command to get the content out. So if you want to put a content from the server side, you need to run 2 commands. First, it's the export, no, it's the publish key. And you can see we have 2 of the publish ones. We have web content and the file content. So I think I wrote them down on the, if we switch back to the server side, I have a little text file here with them. So basically, let's try the first one here. And you can see that you got an error. And if we look into this error, it will say that, yeah, you can only run the SMB publishing on a machine that has the hosted cache set. But we didn't give up there. We thought, well, since bits is actually using the IIS, so over HTTP, maybe the HTTP content, can that actually push out the data? So, very much so. So what we get in our temp folder is basically nothing. And you thought, something's wrong. No. The data is actually done by the export command. So the published data goes and looks at the data and creates the hashes and some information in the branch cache APIs. And then the export command then gives you the file. So depending on the file, of course, this is going to take some time. For the demo, we started out with a 2.8 gig WIM file, and it all works splendidly, but it takes a long time to actually run through the demo. So we skipped it and we actually went with a WinPE image. So my task sequence has a WinPE image attached to it and a dummy command to do absolutely nothing, and that's what we're going to demo. So we get a zip file. You can look into it, and you can basically see that we have an XML file with some metadata in it and some actual catalog with some of the hashes and the data itself. So on the client, I've already actually transferred this. So we move over to my little client, and we look at my temp here. We should see that we have the same peer.dist package actually in here. So we're then going to run the import bc data package command, and then its path, and then the path to the data itself. So when we do that, what happens is that that data is put into the actual the branch cache data source. So the command should run fairly quickly. Yeah, you can see it's already in here. So this is the path that with the command, or this is the path where branch cache is using and storing all its data. So the data is actually imported on the client itself. So I'm going to go ahead and run this. This is basically my task sequence, and to prove to you that it looks exactly as I thought, or what I've created, is go down to my operating system, have a little session, and show you. So it just has a stupid command that does absolutely nothing, and even has an option not to even execute it, but it has a WinPE file attached to it. So you'll be able to see here that this is the WIM file that will pull down. So let's go to the client and see what happens when we do this. So reinstall. The first thing that you'll be able to see is basically if we launch up Task Manager, you'll be able to see that we're starting to, there's actually not a lot of data, or this is a lot of data pulling over the network. So if we go and switch to our config manager server, we could see that there is some data actually coming over here. But it's not so much as I intended. So either I probably forgot to clean out one of the other caches, or they've actually cached it themselves. So we'll be able to see exactly what happened. And this is something that's tricky when you guys go back home to try this technology out. It doesn't work on a single machine very well. It doesn't work if you run it on this and you don't have a high latency. You should really have latency over 80 milliseconds because that's the default branch cache, I think, kind of built-in methodology to get it. So try at least with 3-4 machines having the content. That's where you start seeing it actually working. Or do a package over and over, and the other clients will start using that data. But let's see how it basically seems to have pulled it down. And I'm going to show you how we could figure out what and where did we get this data from. So we can see that it's pulled down. If we now go to the event viewer, what controls this is the actually bits doing the download. So the bits creates a little entry in the event log here. And if you go into the detail of that, you'll see that when the peer distribution flag is actually being set on the advert. So just wait for it to load here. What you're looking for is an event ID with 60. That's where you'll see, and bits will report back what the data, what it's actually done. So what you can see here is the complete number of bytes that we transferred, and also how many bytes further down You can see that we have the peer protocol flag set to 1. That's what we inherited from the advert flag on the advertisement for the task sequence. So that's what tells bits to use branch cache if you can. So it started doing that, and you can see that more or less a lot of the data that it's pulled has been pulled from the other peers. So the technology itself works really, really well, and it's very easy to start using it, but you have to have a lot of machines. It's very hard to showcase good in a Hyper-V environment or in any virtual environment. You have to have physical hardware to try it out. And if you try it as well, try to use a switch or any sort of network connectivity tool that will give you a high latency so that you can simulate that you're actually having a hard time to reach the server. What I've seen when I've been running it is that it sometimes, especially if you run it on a single machine, and this is what I was hoping to show you here, is that as it starts reading its own, basically, if you put it in and cache it into the machine itself, it starts downloading from its own disk. And if you're doing it like I am on slow laptops, basically the latency to get the data from its own disk is getting too high. So it starts looking elsewhere. So even if I'm on a different subnet and my switch is over somewhere else, I still have a gigabit connection to it. The protocol sees that, yeah, I'm actually going to get data from the server faster. So it's actually doing exactly what it's designed to do. So throttle the bandwidth and also try to use a latency of, over 80, because that's what you will see more of the actual benefit coming in. And another beautiful thing that I've found while playing around with this, Phil mentioned that these are the commands that you run from a server side. But I thought, well, would they really write one server component in distributed mode and one component for the client? I wouldn't tell my developers to do that. I would have the same component on the server side as I would on the client side. So would there be anything stopping me from basically taking a bunch of data? So let's take my temp file here. I'm going to copy it into my other temp file. So I have a little bit of data in here. What I'm then going to do is switch over to PowerShell. And we saw basically the publish web content. So let's try to do that. And then it was stage data. See, my mind is not. I'm going to go in and get the command. So what we're doing is basically on the client now. So imagine you're having a task sequence that's doing a download and execute. And what you could do is put in the actual command itself to say, hey, we already downloaded all of this content to the config manager cache. Why don't we just put it into the peer-to-peer cache as well to use branch cache? So I tried the commands, and it seems to be working beautifully. So I'm going to go in here and get the export as well. So what we're doing on the client now, and this is what laptop hard drives not being very fast, but you could have this potentially as you see the demo. Object not found.
Anyway, at this point, we agreed that I would say, we've got some T-shirts to give away. And I actually got 10 T-shirts here, so we were allowing for 10 demo problems, so this is the first one, so that's not too bad, really.
Oh, dear. What am I doing? Ah, yes. You see, the audience is paying attention.
That's why we did it, to see if you would notice. Yes. Very well done.
So let's take a look. And there is a recursive command to one of them. I think it's the stage data one. So if you use the recursive command, it will basically take any file beneath that folder as well. So hopefully this will go better. That really threw me off. But yeah, you see the first command, Ryan Fang. Then we take the second command, and you basically say, yeah, we want to have it. Let's create the file in the root of C. Okay. Export temp, my new data. So we should then have a little new folder or a file. Yeah, that's basically the file that it's creating. So the client itself, when it's downloaded the data, has the authority to publish information using these PowerShell command lines. So that's available from a cache content. So in your task sequences, that's a few of the last entries that you could put in is basically to say, all of the information that I had, I'm going to basically share it out to all of you guys. So it's a very effective way to clear out your config manager caches, but still ensure that you don't download this data over and over and over. And a lot of the way that it works is that since it's using the hashes itself, if you change the WIM file and basically add your patches to it, when it does the download, it's still that the majority of it is actually completely the same. So it'll only download that little bit. So at the moment, using branch cache together with the download and execute, and by always putting the data into your local caches, it's an extremely powerful way of actually ensuring that the data is always available for your clients when you're actually building it. So
there's also some good perfmon counters for branch cache as well. If you are testing, there are perfmon counters in there that can tell you actually how much data you potentially saved by peer caching, as opposed to effectively tells you what it would have downloaded from the server. So I'd just recommend that you check those out as well, because if you're doing some calculations as to whether it's worthwhile or not, they'll tell you straight away.
Yeah, I was just going to try to show that performance, information and tools. Where's the perfmon? Oh. Performance and tools. Shouldn't they be linked to perfmon around here? So admin tools. And performance monitor. Yeah, here we go. I think I did load on this client earlier. I did actually have a data collator set for branch cache. Yeah, you can see I've already been in here. So basically, what it does is it will be very nice for you to show all of the information that you basically put in. So going to branch cache, add them all, click OK. So if I basically go ahead and rerun my advertisement again, you'll be able to see a lot of these performance monitors start going up and down. You can see where it's actually getting its data from when you're doing that. Of course, now it had the, see, it's always the CCM cache. Let me go and empty that. For you, and we can rerun the test again. Cache. So now I've basically deleted my SCCM cache. Make sure it's empty. Yep. So we have nothing on the machine itself, and we'll go and run my download again. So you should now see that what it goes around and do, it will probably realize that I have some information on my own machine, and also it will probably be available on some of my other clients here as well. And it'll pull that down data. So if you want to do reporting on this, you can actually do that as well, to pull in after you've downloaded something. You basically inject this and report this up to say, how much of my data can I get from content? Microsoft IT did an extensive study with this for their remote branches, and we're happy to share with you that URL for that trial for them to say. But they said that they reduced the config manager traffic rate, I think it was up to 80% by just using branch cache in distributed mode. And I think if you start using some of the Windows 8 to import the cache and make sure that you always cache the content as you build machines and run your task sequences, you could probably get it up to even higher numbers than that. So basically ensuring once it's traveled across the link, it will always be used by local machines. So that's pretty much the information that I had to show.
Okay, so that was branch cache. We're still working on this, as it's quite evident, but we're going to post updated information on the blog here. We've got lots of links as to how to do this and updated information as and when we get it. But for now, we are happy to take any questions. We've got a few minutes at the end, and anyone who asks an interesting question will get a T-shirt. But I have to warn you at this point that there's a bit of a parental advisory on the T-shirts, because that's what it says on the back. Oh.
So if anyone have any questions around the demo kit that we've been showing, this is exactly the same kit that we're running down in the expo hall. So down in the expo hall, because the other speaker will probably soon kick us off the scene, come down to our expo hall. We're down there at TIA, the green big setting, and we'll be able to demo this over and over again and show you exactly how the switch working, how you configure it, what doesn't work, etc. So thank you for your time, and hope to see you next year in Las Vegas again.
Thank you.